Hello and welcome to my YouTube channel. I know that I've been doing a variety of things on here, so if you're not interested, I totally get it. I just want to share some more of my passion with the world. I've got a lot of things that I have opinions on and beliefs about that I don't really get to talk about in my grad school or in social environments, so I just want to share my opinions with the world and see where it goes. So today I'm making a video about why I love statistics. Now I get it. Statistics is scary, it's inaccessible, but I think there are very good reasons to appreciate statistics and what statistics can do for society. So I really do understand that it scares some people. I've TA'd statistics courses, and people have been afraid of not excelling in statistics because math is hard. It's heavy math and complicated concepts, which some people just can't grasp in the same way that other people can. A lot of people find that it feels boring, especially when you're talking about the reductive mathematics behind what's actually happening, behind what you're getting out of it. We also constantly see it being used for malicious or incorrect purposes. For example, p-hacking, like you can make a statistic significant even if it really shouldn't be and it's not representative of the population. So I can understand how it upsets people, but we have to find a way to discover what we want to. We also know that statistics are not always correct. So, for example, if you haven't met the distribution that a statistic requires, the statistic you get out of it is not automatically and technically valid. So statistics are not always correct. Sometimes we can find a 90% rate of people getting an illness if they do a certain activity, but it's also connected to a bunch of other things. Statistics have been known to minimize the depth of human experience, and that's why there are case studies where we go into depth of human experience. However, to summarize information from a large group of people, they are quite necessary. Statistics can also go against our common sense sometimes. So we may believe and have a strong belief in something. For example, I think of people who believe in anti-vaccination and refuse to vaccinate their children. Whatever opinions I have about that, completely separately, their common sense says we shouldn't be injecting our children with toxic substances as it might affect them. They're not wrong, but they're going against science. So anyways, it can go against our common sense. And finally, another really negative thing is that it's semi-inaccessible to the general public. Now, a lot of people have taken a statistics class, one or two maybe in college years, but they have not really gotten into the depth of what statistics can do and, more importantly, what they cannot do. Unless you are making a real life example where it's like, oh, so many people get this illness from doing this. It gets a lot more advanced. For example, when you get into personality statistics, we can claim that we can predict about 10% of human behavior, which is a very small amount, but it's also a large amount when you're looking at just personality characteristics. It's way too expensive to access most of these technologies, which makes it inaccessible. For example, if I didn't have a university access, I wouldn't be able to pay for the social package for the statistical sciences, or SPSS, and then I wouldn't be able to run statistics normally. I also wouldn't be able to pay for Microsoft. So that running the statistics is not accessible. Another way that it is inaccessible to the public is that a lot of statistics need you to have a knowledge behind statistics in order to interpret them. For example, if I say, oh, our t-value was 1.9 something, not everybody knows what a t-value is. Not everybody knows what a p-value is. So you do need to have some knowledge of background in order to interpret statistics. Of course, they can be minimized down, but it removes meaning when you make it, oh, 1 out of every 30 people get this illness. When explaining that 1 out of 30 people have this illness, people that are in the general public can understand that, where they may not be able to understand p-values or so on and so forth. However, there are so many things to appreciate about statistics that I don't think students or schools acknowledge all of the time. Statistics makes me excited, and it makes me excited to teach statistics. So I just wanted to share my opinions. First of all, and most importantly, is we have to get this information from somewhere. To make scientifically based decisions, we have to use statistics to get to some meaningful generalizability of our knowledge. Even if it's not perfect, this is where we're able to get a summary of the information that we've collected. It also disproves and proves our intuitive beliefs about nature. My favorite example is a social science example that says either birds of a feather flock together or opposites attract. When we look at the statistical knowledge, it suggests more that people with similar personality traits, people with similar ideals, tend to work better together than those who have completely differing ideals. So it's not necessarily opposites attract. Next, statistics are used to validate the tools that we are using. For example, it is not reliable when some random guy off the street says you'll get cancer if you drink something from Starbucks. That's something that they've made up. So experts will use the knowledge that they have about cancer and about Starbucks to look at the chemical compositions to be able to tell if there is a connection between Starbucks and cancer. They will also be able to rule out alternative explanations like, oh, actually, it's just that people who get Starbucks a lot tend to eat unhealthy food as well, and that's what's causing the cancer. So it is just another way to validate what we're learning. And it's only one of those tools. We can also use experience and other options. The methods, and especially what the computers can do for us, are also very cool. It gives you a number to interpret. So more specifically, it gives you a p-value to tell if the groups are different, or if you're using a different technique, it can tell you, the p-value can tell you that the groups are the same. So it gives you a number to interpret, and it gives you meaning. It also takes some of the human bias out of what we're trying to predict. For example, we prefer to see what we want. We prefer to say that groups are different and be able to show that groups are different through statistics. If these groups that we've said are different aren't different, it can sometimes be hard to accept that idea, especially without statistics. You can add so many variables to try to explain these phenomenon, so you can take out the third variables that you're concerned about that may be making a difference in your analysis. So instead of saying, oh, there's a connection between ice cream sales and aggression, we can take out that third variable of heat exhaustion and see if there's still a relationship between ice cream variables and aggression. And however interesting I think that matrix algebra is, I don't want to make big decisions off of my claims or flawed calculations. So I prefer to just let a computer do it all. And I think that's the most reliable option in most cases for statistics, is to just code the computer to do what you want, so you're not typing in the numbers yourselves. And there are so many statistics programs that will do it all for you. So I really like the statistics problems that'll calculate so much and you don't actually have to do all that much. There are also a lot less calculation errors in computers. and they will tell you what to do and what to think and what its purpose is, and then you just have to interpret from the computer what you take out of it, what the meaning is to you. So it gives you a baseline, and then you can expand on that information. The nice thing with computers is they save you time and stress by having to do things by hand. And here are a bunch of things that computers do that I never want to do by hand. I do not want to calculate the residuals of every y and x value in order to control for another variable. I do not want to run any linear regression by hand, even simple linear regressions, with a sample of more than 5. I don't even like doing correlations, so it's nice that any computer program that does statistics can easily do correlations. Okay, I was interrupted, so I'm just going to start again where I can remember being. I would not want to calculate any multi-level model without a computer. I can barely do it on a computer. I'm never doing that by hand. I would not want to do anything with algorithms and logarithms by hand, because I didn't even really learn how to do it in high school. I'm sure I did, but I never really absorbed that knowledge. Honestly, I wouldn't like to do anything with any more than 5 participants or trials, which, I mean, anyways, like when you're only using 5 participants or trials, that's a pretty sad study. It's a pretty lacking study statistically. So I want to say a big thank you to SPSS for doing it all for me. And I can still look behind the scenes, make sure everything's going correctly, but I would much prefer for them to be able to figure out what they want to do and me just be able to take the statistics from there. Also, if you want drama-filled stories, take a look at the history of statistics. These old men, they just went at each other's throats for every new discovery of statistics. Another thing I love about statistics is, unlike mathematical-based sciences, most of the sciences, it doesn't claim perfection. So it helps us to understand and answer questions and opinions using mathematics in a way that does not claim to have a true answer. It's saying, okay, well, about 5% of the time we would expect to have this finding. So it's not saying, oh, exactly 5% of the time we would expect to have this finding. It's saying, in general, about 5% of the time, using the statistics you had, we would expect to find this finding. And it does not claim to work every time. It's simply probability-based. So it's looking at how many times out of something would this be happening approximately with the sample you gave us. There is no one right answer. No model is ever going to perfectly predict something unless the numbers have been messed with. So you can always say that the model is wrong. It's just trying to describe something that we're seeing. We use data to fit a model that we then use to judge our original data. So that's another way of saying it's a circular process. It's not perfect, but we can constantly improve as we go through time. And it also gives scientists the room to have incorrect opinions and grow with evidence. For example, a lot of studies, especially psychological studies, early in existence were not the most ethical, but we found creative ways to improve on that knowledge and find out what our meaning of truth is, or our meaning of statistical evidence is. So that's really cool that they've been able to keep growing and that statistics doesn't claim that it's perfect. Next, statistics makes most of science possible. We wouldn't be able to know what the meaning is of 7 dead yeast cells in a cancerous body if we didn't have statistics to tell us exactly what that would mean in a human body. So statistics just basically double checks your answers in a less biased way to see if you're finding something or if you want to see something that you're not actually finding. It also gives us interpretable numbers to check our own biases. And it even gives us a way to check if those numbers are unbiased. So it's like a protection of bias of 2 layers. It gives people in science a base to build their models off of. So you're creating a model to try to explain the data. Even a correlation is a model to try to explain the data. Understanding that they will never fully and perfectly explain everything. To account for the complexity of human experience, well, I just realistically don't think any statistical model, even a learning model, will ever do that. It also makes meta-analyses possible. And as a lot of people use the same metrics for different things, you can compile that knowledge and see if you can draw a larger meaning out of it. So if one study out of 100 finds that there is no difference between groups, that's probably meaningless. They probably just had some kind of flaw in the study where they couldn't find what they were expecting to find. And so that gives us a deeper meaning, because it says, okay, sure, one person didn't find what we were expecting, but out of these thousands of other participants, they found it this much of the time, and it's this strong of an effect. It just adds more meaning. And in the vein of it being required for most science, it is also required in most fields, so you might as well try to enjoy what you're going to have to do anyway. For example, psychology is a field where we rely extremely heavily on statistics, both qualitative and quantitative, and we try to use statistics as much as possible to prove our points or to add evidence to our points. Each realm of science seems to have its own goalpost with statistics as well. So maybe we're willing to accept something in personality research because the statistical difference is at a probability of 0.05. However, I wouldn't want 1 in 20 people to go against the grain in a medical example. So for example, if we're saying, oh, only 1 out of 20 women will die from this vaccination, that's a really high statistic. So we can set a different goalpost for medical studies. For example, in IO psychology, you may want to explain 1% of variance of workplace happiness, because that's what they're always trying to figure out. And this 1% would be inconsequential in cognitive psychology, where we're trying to explain higher percentages. Even cognitive psychology would be looked down upon by physics, which uses a very stringent marker for success for any kind of experiment, which we would also hope, because if we're sending a plane, well, a rocket up into space, we really don't want to be losing those astronauts. So you would hope that the calculations that you are running are pretty close to reality. One thing I really love about statistics is it's like an art-based science. Like I said, it's not always true, and it's not going to claim that it's always true. You have to make ethical and intelligent decisions about the statistics that you're actually getting, and about how to conduct and report your results. So one thing that I go through a lot with students is saying, make sure that you don't say a correlation is a causation. So you can't say, oh, one thing caused another thing if you haven't set up the experiment to prove that. For example, we could say that hot weather causes higher ice cream sales because ice cream's cold and people like ice cream. But we wouldn't say that ice cream sales cause aggression because there's the third variable of hot weather that seems to make people more aggressive. And another thing about statistics is you never run out of ways of doing statistics and new things to learn. So it is an art that we are growing and we are developing over time. Point number 7 is it makes you feel like you're smart, even when you're semi-proficient at conducting it. Now, I have taught a few statistics courses now and have really enjoyed them. And that makes me feel smart because a lot of people either don't want to do statistics or can't understand statistics. People don't like statistics and therefore don't want to learn how to do the things in the best ways possible. And I know that maybe it's quite restrictive in some ways because not everyone has education to learn how to do statistics properly. There are some online free options, but not everybody can access the web to be able to run statistics properly either. So, in the end, despite it making you feel really smart, it is slightly restrictive, and that's probably one of my least favorite things about statistics. However, there are free resources like R, for example, that you can just download onto your computer, which is another barrier to entry, but you can download onto your computer for free and run programs through that, and you can still run statistics. So there are options even if they're not fully accessible. And knowledge isn't typically fully accessible. So having options like R is really nice. Statistics keeps evolving. We know better ways to do things over time, especially with high-power computers. Now we can run surveys online and collect thousands of responses and average them and get something important out of them. R, for example, can do so much with the simple statistics you get out of surveys. Stock market trading also uses information gleaned from previous stock market trades to be able to make as much money as possible. We can do a lot with these statistical tools. Number 9 for me is that there are pretty outputs and graphs, and it's getting easier to access these pretty outputs and graphs. For example, I was taking a course in statistics, and there's a tool that creates a perfect little statistic that shows you if the confidence interval is within the appropriate space to be able to call it statistically significant. And it was just a beautiful output that is becoming more accessible because that was in R. So I'm really enjoying the fact that you can create really pretty graphs in R now, and that you can glean the meaning from that. And it's also making it more accessible to a general public that may not be knowledgeable, because you can be like, hey, this block is within the line, so obviously it's significant. SPSS graphs can also be edited to look quite pretty, but you do have to edit them because they come out quite ugly. So it's kind of like a give and take. SPSS is easier than R, it's easier to code, but then when you get the output, it's not as pretty. If you want to go further, you can always plug stuff into Google Sheets or Microsoft Excel, and you can make very pretty graphs. But then you're also not able to glean the same statistics most of the time because they're just not comprehensive statistical software. Finally, the last thing that I want to share about why I love statistics is that it allows us to make powerful, informed decisions. Even though it's not perfect, it can tell us meaningful things about studies that we have done. For example, governments should be using studies and collecting statistics in order to understand what to do, what would be best for their people. These statistics can be done to learn how to help people. And I mean, psychology is a prime example in that realm. If we know that one treatment only works 10% of the time, but another treatment works 50% of the time, we can choose the treatment that works 50% of the time for 50% of people, because that means more people helped. And another thing about statistics is it can scare us into making better choices. For example, if we know that eating very unhealthy food very consistently causes us health risks, let's say, this is a made-up statistic, but eating fried chicken once a week raises the chance that you're going to die within the next 10 years by 20%. If we know that statistic, it can scare us into making better decisions for ourselves and, in the end, for the world. Thank you for watching. I just wanted to make this video and share it with the world to see if anybody else likes statistics and maybe find a community.